class collected data on the number of siblings all the students in the class had. Here is the data collected. A, create a dot plot with the data collected. So a dot plot, first of all, needs a title. So we're going to call this Siblings of Students. Without a title, no one knows what your dot plot is about. You see a series of dots. The second thing, we need to determine the numbers along the bottom of the dot plot. And how we do that, we look for the lowest number in our data, and we look for the highest number, and we write all numbers in between. So our lowest number in our set of data is 0, and our highest is 5. So all along the bottom, I will put the numbers from 0 to 5 without skipping any numbers, because even if there isn't data there, we should show no dots for a gap. At 0, we have 2 dots. At 1, we have 2. At 2, we have 4. 3 is 1. 4 is 2. And 5 is 1. From there, we can answer the question, what is the most common number of siblings? Since the bottom numbers are the number of siblings, I look here for my answer. And I look where the most dots are, and that's at 2. The answer is not 4 because there are 4 dots. They are asking about the most common number of siblings. Question 2 is dealing with a frequency table about the times it takes for 12 students to get ready to go to school in the morning. First, we need to find the frequency, and we find that by counting the tallies. So this tally is 5. This is 4, and this is 3. Adding those up, 5 plus 4 plus 3 is 12. Also in my directions, it says when I do find the frequency, I'm going to round to the nearest thousand. We round to the nearest thousand by going 4 places past the decimal, stop, and round. So these frequencies become fractions, with the numerator being the frequency and the denominator being the total. And I will divide my numerator by denominator and stop and round if necessary. So 5 divided by 12. 12 does not go into 5. 12 goes into 50 4 times. Subtract, I get 2. Bring down another 0. 12 into 20 is 1. I get 8 left over. 12 into 80 is 6. And one more time to go 4 places past the decimal. 12 goes into 80 6 times. I stop and round. The 6 tells the 6 to go up 1 to become 4.417. 4 divided by 12. 12 does not go into 4. Decimal 0. 12 into 40 is 3 times, giving you 36. Subtract, you get 4. Bring down another 0. 12 into 40 is 3. As you notice, you're going to get all 3's here. Still need to go out to that 10,000ths place in order to round to the thousands. So 4 places past the decimal, stop and round. The 3 tells the 3 to stay. And lastly, 3 divided by 12. 12 doesn't go into 3. Decimal 0. 12 into 30 is twice. Subtract. 12 into 60 is 5. 0.25. There is no rounding involved in this question because it terminated before it got to the 10,000ths place. Now we're going to create a histogram from the previous data. And to create a histogram, this table did not start at 0, so I will not have any line that's connecting from 0 to 10. It's not until I get from 10 to 20, that interval, that I will start the data. I will shade up to 0.417, or approximately, and connect. From 20 to 30, I will shade up to 0.333 for that interval, And from 30 to 40, I will go halfway between 0.2 and 0.3 to represent 0.25. I will shade it in. And now I will trace the shape to determine the shape of the histogram. And since the data starts high on the left and then slides down on the right, this is called right skewed. I am going to refresh your memory of the other shapes. When it looks like a mountain, it is called normal. And when most of the data is on the right and it slides down to the left, this is called left skewed. You should know all of those three shapes for your test. Determine the mean of the given set of data. To find the mean, we add and then divide. When you are adding, you should never add more than two numbers together at a time. You should never make one long list. It's too much mental work and it leads to mistakes. I get a total of 81, and to figure out what I'm dividing by, I count up how many numbers I added together. 1, 2, 3, 4, 5, 6, 7, 8, 9. 81 divided by 9 is 9. The mean of this set of data is 9. Suppose that 6 students have the following shoe sizes: 4, 4, 5, 4, 7, 6. What is the mean of the data? So mean, again, is adding and then dividing. So I'm going to add 4 plus 4 plus 5 plus 4 plus 7 plus 6. 30, and I'm dividing it by 6. That's the total number I just added together. And my original mean is 5. To find MAD, I will subtract every number with that 5. So 5 minus 4 is 1. 5 minus 4 is 1. 5 minus 5 is 0. 5 minus 4 is 1. 7 minus 5 is 2. And 6 minus 5 is 1. I will add up these differences. 1, 2, 3, 4, 5, 6. 6 divided by 6 is 1. The MAD is 1. Now always read your directions. You never know. You may have to round with the MAD, and it would be to the nearest tenth. So you would go 2 places past the decimal, stop, and round. Last question, explain in words what the MAD means for the data set in the previous question. You answer this by saying on average. The data is 1 away from the mean. This 1 is going to change based on what you find as the MAD. So you'll insert the answer, your MAD answer, in that space. So if up above in this question you get a different answer, whatever that answer is gets replaced with that 1. On average, the data is blank away from the mean, and you'll fill in that blank. You must memorize this statement.